Today, I'm going to introduce Paul, complicated last name, Brown, and we're going to talk basically about some architectural things and heuristics that really every developer ought to know, and if you don't know about it, you tend to suffer. Now, one of the things is I've had a chance to kind of look at the code and some of the things he's doing in his presentation, and I want you to notice, for those of you that are more advanced and might think you know everything, look at the code that he's done today. And he's put an awful lot in a very small amount of code in terms of concepts and ideas. And sometimes that's the most impressive of all. You know, when you've got that code that's just incredible and just really complicated, the Rube Goldberg code that nobody can understand, that's not necessarily a good thing. But simple code that does a lot with very, very little is incredibly impressive. And today, look at that code, give it some thought if you have a chance, and notice that there's an awful lot that's going on, which is something I'm impressed with. And at the same time, he's going to tell you some of the tricks that he's trying to do, which is kind of like practical architecture, so you don't do stupid things, right? But Paul's had some good experience, and he has a chance to give us some opportunities to understand from his experience in the past, and hopefully we don't come into the same mistakes, because you always learn the hard way, it seems like. So, welcome, Paul.
All right, bad news is I usually try and limit things to no less than 10 PowerPoint slides. Unfortunately, didn't hit that this time. But I tried to keep them brief so we can go through them fairly quickly. Currently, I'm a software architect. I've been a DBA. I've been around Springfield all my life. 25 years experience. When I was writing this slide, I got back thinking about it. And yes, that means I was actually doing computer work before we started using a mouse. I remember buying my first mouse for $45 and thinking, wow, one button. Started in Foxbase. You can see, work with all of the different technologies, the alphabet soup and the different names and everything. I'm mostly a Microsoft guy, so I'm going to go through that. The thing I want to talk about today, you know, I didn't find the page down button on that thing. These are some things, I called it the missing ingredients. They're the things you learn all of this technical stuff like the C# language or XAML or whatever, and they give you all this stuff and they give you the real easy hello world examples and all that. And then they throw you to the wolves and say, here you go develop, okay? Well, there's all that other stuff that over the years you've had to learn. And one of the things I do a lot is I work with a lot of newer developers, and I have to go back and I have to say, okay, here's, you know, you need to learn this or you need to go do this, okay? And over the years, I've learned not to give it to them. Instead of feeding them, I teach them how to fish. So what I wanted to do with this is just basically take a lot of that and put it all together and say, okay, here's the quick 45-minute, if we can do it that fast, speech on that. I want to start off with the cardinal sins, because that's where I start off with all of them. These are the things you don't do. Unmaintainable or unreadable code. The code you see right there, that is code that I've actually had, okay? The guy who wrote it thought he was really cool, and it was absolutely unmaintainable. He got away from it for about a month and a half and couldn't figure out his own code. Bloated code, everything packed into one method, okay? Had a method a developer gave to me to do a code review with him on, had 461 lines in one method. So, needless to say, there was some refactoring. Not doing code reviews. You need to get together with somebody and have them walk through your code. I don't care how experienced you are, you can sit with a junior guy and walk through and you will find stuff, and they will find stuff. Not using version control. Can't believe I still got to say this in 2014, but you need to be using version control. Lots of check-ins. If you don't have your own personal repositories for just stuff you did that you're going to keep, you need to get them. You can't just check everything into the main repository. You got to have your own little personal library. Writing your application as if it's a one-off. How many people here have written an application that's a one-off, and 6 months later it comes back to life? 6 years later? My longest is 2, so. Yeah. So write everything as if you're going to have to maintain it on a daily basis, because then when you get called back to it, you can remember it. Own your code. Okay? And what I mean by that is own the code you write. When it goes in, if you just copied it off of somebody's blog post, you better know what it does, because you just put it in the code base and it's your responsibility. If you got code that you go, well, I just copied it and it works, that's called magic code. Okay? If you got code that's put in there by a wizard, that's Wizard Wonderland. Okay? This is all stuff you don't have to know exactly how it works, but you need to have a good understanding of what it's doing. Not knowing the reason why you did something, okay? This is a classic one I get all the time. People don't know why they did it. They just did it. And so when we go back and I'm like, well, why'd you do it? I don't know. It's like working with my teenagers, okay? They sit there, stubbing their foot. Know why you did it, because if you know why you're doing something, you can break the rules. There may be a valid reason for doing something that's against the rules. Okay? You may denormalize a database just because you need performance for a management report. It's not the greatest thing in the world, but it's a valid reason to do it, unless you can come up with some other solution. Last thing is forgetting that somebody's paying for your time. Okay? Whether that's your employer, if you're self-employed, you're paying for your own time. Somebody somewhere is paying for your time. You need to be responsible to them and provide them with good quality code that you can maintain over time, and somebody else can come in behind you and maintain. All right, some acronyms and memes that you can use as you go through. This just makes it easy to remember some stuff. YAGNI, you ain't gonna need it. Basically, only work on the stuff you need. Okay? Work on what's in the spec, what's in the current sprint, whatever you've been assigned to work on that. Don't worry about adding features. You can spend your time better on the necessary functionality. If you add a new feature, it's got to be debugged, it's got to be supported. It could constrain some other feature in your application. Worst part is you write it. Okay, that's great. You wrote it in isolation. Now the user actually goes to use it, and guess what? It doesn't work for them. If you're adding features in, you get code bloat. You got stuff that's in there nobody's using. You start adding in one feature, pretty soon you're adding the next one, and the next one, and all of a sudden you've got feature creep. And again, go back to number 1, which goes back to one of the cardinal sins. Time could be better spent on necessary functionality, okay? Somebody's paying for this. You need to develop what they need and what's in the scope of what you're supposed to be working on. Keep things dry. Don't repeat yourself. This says single representation of truth. That's kind of the canonical definition. Basically, don't write something that does the same thing as something else. Worked with a system where they had 3 different ways of calculating an invoice. So guess what happened about 6 months after it had been up for a while? Customer called and said, I got 2 different invoices. Okay. Then more customers called. And when the customers called, the ones who had gotten the low one and they were actually supposed to pay the higher one, guess what they said? I'm only paying the low one. The customers who got the too high one, they were already mad when they called. When you keep a good way to keep yourself dry and to know you're keeping yourself dry is changes should only impact the related elements. If you got to start hunting around, going all over the place to put changes in, that's an indication that you're not dry and you need to start looking at refactoring. And this is the one Mark enjoyed the most. The opposite of dry is wet. We enjoy typing. So for some reason, if you like typing the same code, that's not good for you. And over again. Yeah. I think you were supposed to ask for the mic before you put that in there. Keep it simple, stupid. I have heard this since I was probably about 12. Every job I've been on, it's keep it simple, stupid. Write only the code you need to get the job done. Don't start writing extra code. Don't worry about what that piece is going to do or that piece is going to do or how it's going to do it. If you're the only guy working on the app and you start worrying about the next piece down the line, pretty soon you've worked on 6 different pieces and you've never finished one of them. If you're worried about what the other guy's doing, worry about it when he turns it in and you do a code review, okay? If you agree to an interface or a contract, you're golden because you can say, that's what we agreed to. Now you may have to renegotiate, but you built to the contract, you're in good shape. Everybody in here needs a new uncle. If you don't recognize the name under there, then you definitely need a new uncle. Robert C. Martin is a guy who has written extensively on software craftsmanship. His nickname is Uncle Bob. He is just excellent at writing about developing good software. Google Uncle Bob, start reading it, pick up a couple of his books. I got one book I think was put out in 2001, and I pulled it out the other day and looked at it again because it's still relevant and it's still practical. Some of you may have heard of Solid. Uncle Bob coined Solid. His Solid principles these are the 5 principles you need to use for development. Single responsibility. A class should have one and only one reason to change. Okay? What that means is a class should do one thing. Because the only reason it's going to change is if that thing it does changes. Open and close principle. Okay? You should be able to extend a class's behavior without modifying it. Okay? Open to extension, close to change. ListGov substitution principle. A derived class has to be substitutable for the base class. So if you inherit from a class, you need to be able to use that child class any place that the parent class is used. So if you're getting barked at by the compiler because you're doing that, that's a hint. Interface segregation principle. Use fine-grained interfaces. Make them client-specific. Make them small. Dependency inversion principle. Depend on abstractions, not on concretions. Okay? Don't depend on an actual this instance or this specific class. Abstract that out so that you can use small pieces to build bigger things. Some techniques we can use. Program to an interface, not an implementation. Okay? We talked that interfaces should be fine-grained, they should be small, short, and limited in the number of methods and properties. I kind of just did a quick thing, and I don't think I can find anything in the .NET framework that has more than 10 methods and properties. Okay? I'm sure there is something somewhere buried in there, but I wasn't finding it very fast. When you use an interface instead of an implementation, you get loose coupling. You can substitute different classes as long as they meet the interface. You really don't care what it is as long as it does the job. Believe it or not, if you use an interface, you can write test method A that depends on I class B, it's an interface, notice the I at the beginning, without actually writing an implementation of I class B. So we finally get to some code. Okay, pretty easy one. I have an interface example, and all it does is change, oh shoot, sorry, it did not copy off the drive. Let me jump over to that real quick. $10 says this test doesn't work. Okay, we have a name changer class that changes everybody's name to Paul. Good name, I like that one. And we have an interface I class B that has a name. Okay, so if I go over here and I say name changer should in my test, I'm going to test the name changer, but I have absolutely no implementations of I class B. Okay? Run my test. Please run. All right, I'll just run them all. And let's see, change everyone. Well, we can see that that one passed. Okay? And if you're wondering, I used MockU to do the implementation of the interface so that you'd supply the mock to the test. Okay? So using an interface, we can test only the code we're writing and just the code we're writing. And it's fast. So you can run these tests all the time. Composition over inheritance. Okay? When I first started working with Fox Pro, which became an object-oriented language, first thing everybody did was they subclassed all of the base types. And then everybody went crazy with inheritance. Okay? And since it was all new to us, it didn't take long before, or we kind of actually got by for a little while, and then we started getting bit by the inheritance bug, and we finally realized, wait a minute, we needed to back off. Okay? So composition over inheritance means build little pieces, okay, and use them. If you think of a Lego, okay, we've got this real nice little Lego. We got a bunch of Legos, okay. We can take all those little Legos and we can build ourselves a Lego Death Star. Okay? Now, how in the world are you going to build a Lego Death Star with inheritance? Can't do it. Biggest thing about composition over inheritance, it encourages dry. It encourages you to reuse things so that you just sit there and you're like, okay, I wrote that once, it's done, it's tested, I'm good. I don't have to go back and rewrite it. Pair programming. This is where two developers take turns writing code. Your biggest difficulty in this, and I probably should have put it on here, is going to be getting your bosses to understand the two people sitting at a desk writing code is actually cost beneficial. It really is. When you've got two people sitting there writing code, you get good discussions about design. You've got built-in code review, so you don't have to go back because it's already been reviewed. It helps build good coding practice because somebody's actually watching you. Somebody's looking at your code and saying, you're really not supposed to do that. And it can be used to help transfer knowledge. Now, easiest way to think about this one is, okay, I've got a senior developer and a junior developer. Great, okay? Yes, that can be a great knowledge transfer. How about we got the new guy who just came in and he knows whatever flavor of jQuery or whatever is out there now, and you got a more experienced person over here who hasn't really dealt with that. They can get the same knowledge transfer. One thing, please use deodorant. That's experience. And no, I was not the one who forgot it that day. Refactor. Okay, build it so it works. Then go back and review your code. Can you apply any design patterns? We're going to talk about a couple of design patterns here in a minute. Are there any dependencies? Are the names appropriate? Any long methods or classes? Okay. If anybody sat down on a marathon, I'm going to code this baby out and I'm going to get her done, and then you get done and it works, it passed all its tests, but it's ugly code. Go back, look at it, say, hey, do I need to change names? Because probably the way you used a variable changed at some point as you went along. Might need to make a couple iterations of it. As you get better at it, the number of iterations will go down. And then one thing I like to do is before I finally tuck it all away and say I'm done with it, I go away from it for a little while and come back and take another look at it just to double check and make sure I've done everything I can. All right, pop quiz. Who can name the 4 patterns that make up the original Gang of 4? Nobody? Seriously? Lee, I got to say, I figured this one was right in your wheelhouse.
Yeah, I just don't remember the original one.
All right. Well, it's a trick question. The Gang of Four was actually the four authors who wrote the book, Design Pattern Elements of Reusable Software. And there's 23 patterns in the book. They're grouped behaviorally, and it's a really good book. It's not the, you're not going to spend a lot of time at night staying awake reading it, but it's got a lot of good stuff. These are some common patterns I usually end up teaching some folks as we go through things. Some of these patterns I hit, especially like the observer, a lot of the web guys who come in and they don't have a lot of domain development experience. They've been doing web, and it's like, you know, they know JavaScript and they know Angular and they know Knockout and all these other things, but they really haven't had to build that domain-specific core. Everything's been working on the UI. So that's why the observer's in there. The other ones are ones I guarantee I use them just about every application. So the observer class or observer pattern is used to notify other classes that something's happened. Okay. Classic one is the events. Okay. Click happens. It happens, and then somebody notifies everybody else and says, "Hey, the user clicked the mouse." Okay. So we're going to take a real quick look at the observer. And this little guy is pretty practical for today, because the game manager's job is to keep track of who's going to attend the game and let them know that the game got canceled. One of these days I'm actually going to write an app that does this so I can not have to send an email to all the team and say the game got canceled tonight because it rained all day. And they don't have Windows, so they obviously couldn't see it raining. So we basically have two classes with a game manager and a spectator. Okay? So the spectators, we're going to go over here to our unit test. Let's see. So basically what happens is we new up an instance of game manager. Bobby's mom and Billy's mom both let us know that they're there, or that they're going to attend. The game gets canceled, and then we want to make sure that both Bobby and Billy's moms know. Okay? So, record attendee just adds them to the spectators collection. So now we're keeping track of them, so we know who's there. Okay? Oops, wrong one. Billy's mom, same thing. Then we cancel the game. And all we do there is we iterate through the collection of spectators, and we call the tell me game is canceled method, which then sets the I know game is canceled property. Okay? So, save a little time. I'm not going to run that again. Let's see, where is it? Notify everyone when game is canceled. Everything was green. Okay, so that's class. That's pretty much a standard one on the observer pattern. Decorator. Decorator is to extend the functionality of a class without changing the original class. Okay. When you introduce change, you introduce the potential for bugs. Okay? In a physical example, not a software example, when does a wire cause you a problem? When it's moved. If it's sitting there and you've done nothing to it, 9 times out of 10, that wire is going to be good forever. As soon as you move that wire that's been sitting there for 5 years, you're going to have a problem with it, right? Okay. From a software perspective, if we don't change the code that's existed and tested, our chances of introducing a bug are very slim. They're not zero. Okay, I want to be very clear because you can still have unintended consequences and introduce a bug. And this is a great time to use interfaces and composition to do what you need to do. All right, so we're going to look at Decorator here. And I borrowed quite a bit of this from Head First Design Patterns. So yes, thank you for all of the stuff, but I did get help from a book. Basically, we have a abstract class. We want to deal with abstractions, okay? And it's a beverage. Okay, so we got a house blend, a decaf, an espresso, a dark roast. Then we have all of our condiments, okay? Notice that beverage, or the condiment, inherits from beverage, okay? So we have all our condiments, and basically all we do here is we tack on the description to the beverage description, okay? We tack on the cost, and we pass in the beverage into the constructor each time so that we can keep track of what beverage we're getting in, okay? All right. So if we run our tests, we have a white chocolate mocha. It's $4.50 and that. So we've now just decorated that. If we extended the functionality of beverage without changing the beverage. I can go in, I can add all the condiments I want, and I never change beverage. I never change any of the other classes. Does anybody see a problem with this code? I'm going to flip over to the class design. Notice the line between condiment and beverage. What happens if I change beverage? It impacts all my condiments, which technically, if you want to get specific, really aren't beverages. Okay, the coffee's a beverage. Okay? So, let's go back to the other slide. We said we wanted to use interfaces and composition. So we did a little bit of composition there. Okay? Did we use an interface? So if we abstract out to an iBeverage, now both beverage and condiment can implement iBeverage. They're not dependent on each other. They're not related to each other other than the fact that they both implement an interface. So each can do whatever it wants and behave however it wants without actually changing the behavior of the other, okay, or impacting it. So if I go back and I look at my code, there's iBeverage. It has a get description, get cost. Okay. Abstract class beverage implements iBeverage. Okay. All the other classes inherit. Okay. Want to kind of point that out. Inheritance is not a bad thing. It's just something that you know, it's not the I have a hammer, everything's a nail thing. It needs to be used on a limited basis. Now look at all my condiments. My condiment implements from iBeverage. And it still does the same, pretty much the same behavior. So it's a very small, subtle difference, okay? But it will allow you a lot more flexibility in the future, and it reduces the possibility of introducing an error. And that's just kind of an example of how they're wrapped around each other, okay? Adapter, this is one I use a lot. I do a lot of work with related systems or getting data to and from somebody else's system into one of my systems, especially mainframe stuff coming down, things like that. So adapters are something I use a lot. They're really useful business to business, mainframe to PC, legacy to current applications, okay? So if you're working on a lot of legacy stuff, you may be able to use adapters to get around having to go back and rework some of the code with your legacy stuff. In other words, it can stay in place until you can go back and rewrite it. All right, so let's look. Actually, I want to hit that next slide, sorry. So we have two businesses with clients. We have ABC and XYZ. And ABC calls people by first, middle, and last, whereas XYZ is first name, middle name, and last name, okay? So we create two interfaces, IABC client and IXYZ client. We put the adapter in the middle, okay? it implements both. Adapters can be one-way or two-way. In this case, we're going to do a two-way adapter. So we're going to implement both of the interfaces. There's my IABC client. There's my implementation of IABC client. XYZ client, both the interface and the implementation. And here's my adapter. Okay? Now, because it's two-way, I have to have a first and a first name property, a middle and a middle name, and a last name, and then a client ID. Okay? But you notice by using the adapter, the fact that XYZ has a client ID and ABC doesn't impact each other. Okay? So, as a practical example, we have a registrar, and his job is to register clients. Okay? So he's going to take an ABC client, and he's going to register that client, and we're going to, the test double checks to make sure. All right, and allow registration of an ABC client passed. So we know that worked. Let's take a look at that method. First off, notice register client. What does it take as a parameter? Keith, you're on the hotspot. Okay. So all it's looking for is something that implements XYZ client. Okay. So by passing in the adapter, which implements IXYZ client, we can do whatever we want with it. Even though it's not the actual implementation, we've just substituted something else to handle registering that client. Okay? Again, since we use the interface, when we wanted to test the register client method, again, we don't have to actually have an implementation of IXYZ client. We can mock it up and roll on. One of my favorite patterns is factory. Okay, I think it's one of the most underused patterns around. You probably use it on a regular basis without realizing it. A factory makes objects. Simple, easy thing. Okay, it allows us to construct objects in a consistent manner. We can avoid complicated constructors. Okay. So if you've ever sat down and looked at somebody's code and they got 8 constructors on an object, it's probably a good time to think about making a factory method for it. We can hide complexity. Okay. I'm going to show how we can basically hide the fact that we're going to do a whole lot more than just run that one method. But all the clients, everybody who consumes that factory, is going to just see the one method. You can also create objects with internal constructors. So if you ever wonder how you get stuff out of the framework that you can't new up, basically they're using a factory method to give it to you. Okay? Good rule of thumb, if building an object is complex and the class itself is complex, then you probably should be looking at a factory. Okay? Oops, wrong one. All right. If anybody can't guess, my favorite drink from Starbucks or just about any coffee shop is a white chocolate mocha. Okay? And yeah, they're usually about $4.50. Wish they weren't. I would probably have more. Okay. So, first off, who can tell me where the factory method is? Go ahead. Just shout it out. Huh? Shop.make. Okay. So we got one line where we're calling our factory, right? So that looks like it's probably, it's pretty easy. We don't have to worry about it. This is what all goes on behind make. Okay. First thing we do is we take our menu item and we make a coffee order. Now, I'm going to preface this with, yes, there are other patterns that could be used with this, removing some things out to other classes. Just take it for the example that it is. Okay? So we're going to make a coffee order. When we make a coffee order, first thing we got to do is figure out what kind of coffee. So we got to get everything listed. If we go down here to white chocolate mocha, we'll see that's house blend, add mocha, add white chocolate. Okay? So that sends back a coffee order. We now have translated our menu item to a coffee order. Now we call an overload of the make method, which is protected, and it actually makes it from the coffee order. Okay? So the first thing it does is it gets the coffee blend. All right? All that does is say, hey, return me one of the different classes that's my coffee. Okay? So we've got our beverage. Go back up to the make. Now we need to add the condiments. Okay? So we've got the coffee. We pass in the order so it knows what to do. And here you can see we just keep passing in. And all we're doing is we're using those very same classes we used from the Decorator. Okay? So all that's doing is it's taking those in and it's just saying, hey, keep adding those on, keep adding those on. And when it's done, it returns our coffee. So whereas the consumer of make sees one selection or one method call, there's a ton of stuff going on behind the scenes just to make that white chocolate mocha. Okay? It's the same thing in the .NET framework when you work with it. It does it. When you pass in an enum, off it goes, which is basically all I'm doing here is I've got a coffee type enum and a menu item enum and then and then my methods. Keith, you got that for a reason?
Yeah. Is there a reason why it's not static? That method isn't a static? I didn't see it. Do you have a factory interface for that? Is that?
No, I just newed it up.
Okay.
It just wasn't thinking performance issues, stuff like that. Just was trying to get a good example that hid the complexity. So.
Gotcha. Just curious.
Yeah. My factory methods do tend to be static unless I'm doing things that maybe I want to hold on to some resources, file system, database, stuff like that. When you look at solid, inversion of control dependency injection is called a principle. I think of them as patterns. Okay, that's why I put them in here. I think of it as a pattern rather than as a principle. There is a difference between IOC and DI. I'm going to let you figure that out for yourself. Okay. Biggest thing that you're going to find with IOC is it makes unit testing a whole lot easier. A whole lot easier. I think we've already seen some of that, but I'm going to show another example here in a second. It allows you to only worry about the code you're writing. So you don't have to worry about anything else, okay? Because you know all that's coming in, you're just working towards whatever the interface or contract is. You're not worried about, did that object give me this or give me that or whatever. IOC prevents you from introducing unintended side effects, okay? Notice I don't say bugs, because a bug is something that doesn't work and the user tells you it ain't working, okay? But you can have an unintended side effect. You ought to be using IOC in every application you write. Every application. And there's all sorts of DI frameworks, and I can't think of one of them. Ninject is the one that's popping in my head. What's the pattern? Enterprise Patterns and Practices one? Unity. And then what? Then Castle Windsor? Yeah. Okay. And you can actually roll your own. There's a couple of real good examples of rolling just a real simple one for smaller applications when you don't need a ton of stuff. Okay. With NuGet, you probably don't need to roll your own anymore because it's pretty easy to get those. IOC, if you're using Entity Framework, it's your best friend. And let's run over here, and I'm going to show you an example. Now, I did not install EF on here because I didn't want to run out to a database and do all the other stuff. Okay, so we have a client, we have a data context, which for the sake of argument is going to make a call to our database. Okay, and we have a repository that saves a client. Okay, all right. In my repository, you notice I'm newing up a data context. So can I write a unit test for this method?
No, because you have to do up the context.
And where's it? And if that's truly going to the database, where's it going? If that data context truly went out to the database, where's it going to go?
With what kind
The data context. When you call a method on that data context, it's going to go out to the database. So it's going to be an integration test rather than a unit test. Okay? And integration tests are slower because they go to resource intensive or resources that take more time. Okay? So we want our unit tests to be fast, and we only want to test the code we're working on. If we actually run that, it's going to actually test the data context. So we're testing more than we want to. All right. So if we write our repository this way, we create an interface, iData context, and we pass in the data context rather than newing it up using our interface. We can test all day and never touch the database. Trying to think the last time I looked at the count. We have an application that does quite a bit of fiscal manipulation and stuff like that. It's got right around 1,200 unit tests. Okay? It takes a couple seconds to run. I mean, yeah, there is a noticeable lag, and I'm starting to think, okay, maybe I need to go back and prune the tree. Maybe I don't need all those tests. But when you're dealing with the money side, you want to make sure your calculations are working correctly. But since they don't go to the database and they don't do anything more than just the lines they're the lines they're testing. Okay. All right, we're almost done here. This is one a little more for the people who are either new to .NET development or just new developers. Separate your stuff into layers, okay? The layers are logical, not necessarily physical. You can use separate projects if you want. If it's a small enough project, just throw them in different namespaces. These are some common namespaces. When Mark and I were talking about this, we actually both kind of used pretty much the same terminology. And I think you'll see most of this is pretty common. You've got a shared common. That's code that's shared across layers. Okay, that code should work pretty fast. Very few, if any, implementations or actual concrete objects. Okay, it should just be like extension methods, static methods, stuff that just does something and it gets it done and it's done. Your core should be your business logic. Okay, your infrastructure should be talking to your database, your file system, any resources that basically take more time. Okay. Avoid putting business logic in the infrastructure layer, especially if you're using Entity Framework. Okay. One thing, and I made this mistake for a couple of years before I finally sat down and really thought about it. You don't want to put your business validation inside the Entity Framework. Okay, you want that to stay out of it. Okay. One of the holy grails was, we want to be able to move from SQL to something else. Well, I've never actually moved an application from SQL to something else. Okay, but I did have to jump from LINQ to SQL to Entity Framework. So I kind of got bit in the butt by that, and now I've kind of figured out, okay, I need to work on that. You want to use interfaces between layers. Okay, so if you're talking from one layer to the next, have an interface that describes the contract that you're agreeing to, and then you should have a default implementation so that the user doesn't have to code one. Okay, and if you have to, use a factory method to control creation of that default object. Test, test, test. No, that was not for him. At a minimum, you must unit test. Test only one thing at a time, one small piece. Don't test a whole bunch. I know I've seen it because I wrote it. I've written tests that tested a whole bunch of stuff and realized, wow, that's a terrible test because it's extremely brittle, and the first time I changed something, I had to go back and I had to fix my test. You need to do integration testing. You can't just unit test. You have to do integration testing, especially if you're using LINQ, because there's a lot of stuff that those trees can't translate to your database. Okay? ToString, I think, is one of the most common ones. Learn the different types of testing. There are a ton of different types of testing. There's alpha testing, beta testing, acceptance testing. What was the one you came up with? Spec testing? Spec testing. You've got unit testing, integration. Huh? Okay. Regression testing. There's all sorts of stuff. Learn what they are. You don't necessarily have to use them all depending on the size of your shop, but at least know what they are. Know that they're out there, because if you decide you need it, then you can go find it. But you can't decide you need it if you don't know it exists. And we'll skip reading number 1 out loud. It's starting to smell in here. Code smells are signs that you need to rethink what you've been doing. Common smells. Your comments are as long as your code. Oh, have I seen this? The mainframe guys that I used to work with, man, they were. I'm like, what is all that? They're like, that's a comment. Wow, okay. If you have long methods or classes, like I said, I saw one that was 461 lines long. Okay, if you got a big class, you need to look at, can I abstract some of that? Yes, sir. Give him a mic. He's been dying back there.
A couple of guys here know, had to work with some classes where you had no idea where things were changing. There were 6,000 to 10,000 line classes. The difference between them were anywhere between 1 to 4 lines of code. A little bit of a smell?
Yeah. That would be in the, you keep having to change a class, or there are 2 classes that do the same thing. Okay? If you got to keep going back and changing a class because you're doing something else and you're like, oh, I got to go back here and change this again. I got to go change it again. I got to go. You got a problem. Okay? You need to look at that code. If you got 2 classes that do the same thing, you do not have a single representation of truth. Because one of those classes is going to get modified and the other one's not. And all of a sudden you're going to get 2 different answers to the same question. This is kind of a subtle one. If the compiler warns you that you're hiding an inherited member, that's a code smell. You've done something you really should be thinking about. Why am I doing this? Before you just say, okay, that's fine. Yeah, go ahead. I don't care. If it's hard to unit test, you got a problem. You need to go back. You probably need to use dependency injection. You need to look at an interface, a ton of things. If it's hard to unit test, if you're sitting there and you're banging your head trying to unit test something, chances are refactor. Best thing to do, work on it for a little while. If you can't solve it, have somebody else take a look at the code. Okay? I got a friend that works over at Realtors. He sends me code all the time saying, hey, take a look at this. Because he came from the AS400 world. He's working with VB and C#. He sends me stuff all the time. You know, every once in a while I'm like, holy crap, what are you doing there? But most of the time I look at it and I'm like, there it is. And he's like, I've been spending 5 hours on it. Okay? And I periodically send him code and say, hey, this thing's kicking my tail, take a look at it. Okay? If you Google code smells, there are a ton of sites. There's actually one site that's trying to do like a wiki thing with code smells. I don't agree with all their code smells. But again, they're smells. So you look at it. If you decide the reason you're doing it is valid, you move on. So to wrap up, basically development's a process. If we develop good practices and use those practices, like always writing clean code, understand our code, own our code, okay? We make small things that can be used to build larger stuff. We learn the common patterns, work with the common patterns, organize our stuff so it's all logically arranged. We test, and test again. And then we refactor to make sure everything's clean after we're all done. You'll have good code. You won't have the kind of bugs that you're sitting there banging your head, or worse, the user's calling and saying, why does this do this? This seems like a basic thing that it should not happen. Okay? And my wife is a classic case. She has a Windows phone, and she looks at me all the time and she goes, why does it do this? Why did Microsoft not test? She's not a developer, by the way. So, under an hour.